Part of this lesson is going to be review. We're going to talk about domain and range. We're going to talk about axis of symmetry, which is something we discussed yesterday. We're going to talk about x-intercepts, concept from algebra, y-intercept, just little things, okay? So we're going to be given the equation. We're going to have to find these things. Now, yesterday we focused on vertex. That's part of a quadratic. Today we're going to focus on the smaller things. Example 1. We have a quadratic equation. We're going to answer several questions about this quadratic. We have 3x squared minus 24x plus 36. Anyway, before we can figure out domain, range, and all that kind of stuff, we need to find AH and K. Again, I don't want you writing this down. Just follow along. A, B, and C are the coefficients of each of those terms, just like we did yesterday. Here is the equation for the vertex, which we learned yesterday. Then we just plug that stuff in and simplify. Again, I'm not going to focus too much on this. You get negative 24 over 6. Make that negative, becomes positive 4. On the right, you would square 24 first, which would be 24 times 24. There's a mistake here. Oh, no, it's not. 24 over 12 becomes 2, so you can actually divide before you multiply. That would be quicker than doing 24 times 24 over 12. So 2 times 24 is 48. 36 minus 48 is negative 12. So go ahead and write this part down. Once you figure out the vertex for negative 12, then you can write out what h and k are. Which is why yesterday we just focused on finding AH and K, because it'll make today a lot easier. So the question is, what are we going to do with H and K today? We know the vertex is 4, negative 12, but what about this other stuff? Somebody asked this yesterday. How do we know if it's opening up or down? And I alluded to that. It's pretty simple. If A is positive, so whatever that leading coefficient is. So for example, guys, in this case, the leading coefficient is 3. That's positive, right? Now, if A is negative, which, guys, we will look at an example where A is negative. Go ahead and just write the rule down for now, though. If it is negative, that parabola will be pointing down. In this case, A is 3, leading coefficient, so it's going to be pointing up. So what he said was, will there ever not be an A? Well, if there's no x squared term, then it wouldn't be a quadratic. If there were an x squared and there's no coefficient, then that's implied that it's a 1, right? So there's still technically be an A, and it would be pointing up. A good question. Okay, the next thing we're going to look at is domain, which is probably the easiest thing on here, guys. This is actually review. We already talked about the fact that if it's a polynomial, it's all real numbers. A quadratic is a polynomial because all the exponents are whole numbers. So therefore, no matter what the parabola is, no matter what the quadratic equation is, the domain is all real numbers. Real simple. Next, we're going to talk about range, the rule, which I will explain because it's a little confusing, I guess. It depends on two things. It depends on A and it depends on K. Again, remember, 90% of the work is finding AH and K. So, first of all, we know that if A is positive, it's pointing up, right? Well, that must mean that the range is going to start at the y value of the vertex, including it, so bracket, and it will go to infinity. All right, I'm going to draw a picture of this to help you understand that. I'll go back to the rule in a second. I just want to show you what this would look like. So let's just say we had a parabola, and it looks like this. And let's say this point is, 4, 5. That means the y value is 5, right? Well, that means that the range would be everything from 5 to infinity. 5, infinity. Good. So it would just be k and then all the way up. Now, good. Now, if it was pointing down, if a was less than 0, it would be negative infinity to k. And what that would look like, so let's just draw a parabola pointing down. And let's say this point was 6, negative 2. That means the y value is negative 2. Well, the range would then start at negative 2, and it would go down to infinity. So that's why we have this rule. If it's pointing up, it's k, infinity. If it's pointing down, it's negative infinity up to k, and including k. In this case, we found out k to be negative 12, and a is positive 3. So therefore, the range would be from negative 12 to infinity. Because it's pointing up, we're going to start at the k value and go to infinity. That one's going to be something you might have to reference a lot when you're doing the worksheet. Now the next rule is going to be much simpler. We already talked about this actually. Axis of symmetry. It's always x equals h, and that's because we talked about the fact that for a parabola, the x value of the vertex is the axis of symmetry. I'll go back to this in a second. But for example, here the axis of symmetry would be around x equals 4. It's the x value of the vertex. All right, here it would be x equals negative 6. Sorry, positive 6. So it's just the x value of the vertex, which happens to be h. So the axis of symmetry is always at x equals h. In this case, we found h to be 4. That means the axis of symmetry is x equals 4. Remember, the axis of symmetry is an equation. It's a equation which represents a vertical line. Axis of symmetry cuts the parabola in half. But next, we already talked about the vertex is just hk. We spent all day on that yesterday. So in this case, the vertex is 4, negative 12. All right, next is a review. I know some of you, and you know what, maybe next week we will review this because some of you might not know the x method. But next is x-intercepts. X-intercepts is where a graph where in this case where the parabola touches the x-axis. And so, for example, let's just draw a little graph here. Say I have a parabola like this. Okay, the x-intercepts would be where it touches this x-axis, and they're points, by the way. So the question is, how do we find those 2 points? Well, notice it's wherever y is equal to 0. So to find the x-intercepts, we set the quadratic equal to 0. Now, the first thing we're going to do is simplify this. I noticed that all 3 of those terms have a 3 goes into it. So we're going to divide both sides by 3. You're still going to have a 0 on the left because 0 over 3 is 0. So we'll have 3x squared minus 24x plus 36 over 3. So 3x squared over 3 is going to give you x squared. 24 over 3 is going to give you 8. And 36 over 3 will give you 12. Here's to simplify it.
Oh, okay.
You're still going to have 0. Yeah, you're still going to have 0 on the left because 0 over 3 is 0. Now here's where the x method comes in. And again, I'll probably actually next week, maybe Monday, we will just spend a day or 2 on this. The way the x method works is take the coefficient of the first term, which is 1, and you multiply that by the last term, c. So 1 times 12 is 12. That goes on the top of your x. What goes on the bottom of the x is the middle term, in this case negative 8, or the middle coefficient, I should say. And then what you do is you want to find two numbers that multiply to give you 12 and add to give you negative 8. It takes a little bit of work, but notice that if I take negative 6 and multiply by negative 2, I get positive 12. And if I take negative 6 and I add negative 2, I get negative 8. So these two have the sign up here at the top. Those 2 numbers have to multiply to give you the top and add to give you the bottom. Well, Yeah, you technically need to.
So add to equal, or multiply to equal C, and then add to equal.
It'd be multiplied to give you A times C is what goes on the top. Remember this coefficient times C gives you the top. So if the coefficient
I'm
for
looking for two numbers that equal 12, which is C. Right?
12 is not C, 12 is A times C. If this number was 2, then C would be 24. I mean, the top would be 24. It'd be 2 times 12. Okay, that's why we're going to review this. But anyways, for now, you can see that -6 times -2 is 12. If you add it, you get -8. Now here's what you do with these two numbers. So this -6 and this -2 is the two numbers we're going to use to factor. And what we're going to do is break down the middle term in terms of those two numbers. Since we got -6 and -2, we can break down -8x as -6x minus 2x. After all, that does make -8x, so it's not like we're technically altering the equation. We're just breaking it down into two separate terms. Then what you do from there is you pull out a GCF of the first two, which would be x. X goes into x squared, and it goes into -6x. Then you have x minus 6 left over. If you remultiply this, you'll get x squared minus 6x. All right, then you're going to pull a 2 out of these two, or sorry, a -2. So you get -2 times x minus 6. And then the final step for this factoring is whatever's in these parentheses should be the same if you did it correctly. So that's going to be your first factor. Whatever's left over, in this case x minus 2, is going to be your other factor. So then we have x minus 6 equals 0. And we're going to solve. So basically, we're solving each of these. We're going to solve that one first. If we solve for x, we get x equals 6. Then we take the other factor, which is x minus 2. We set that equal to 0. And we get x equals 2. Those are our two intercepts. So that means that the graph crosses the x-axis at x equals 6 and x equals 2. And that's going to be our x-intercepts. Notice they're points. So we have to take the 2 and the 6 and make them points. Well, for an x-intercept, y is just going to be 0. So the two intercepts are 6, 0, and 2, 0. All right, one more thing, which is actually probably the easiest, is y-intercept. Recall that when a graph crosses the y-axis, let's make another one here real quick. What is the x value when a graph crosses the y-axis? What's the x value there? There is one. What would it be? 0, right? Here's x equals 1. Here's x equals -1. X is going to be 0 whenever the graph crosses the y-axis. So to find the y-intercept, just plug in 0 for x. Okay, so every time there's an x, just plug in 0. And in this particular case, we get 0 plus 0 plus 36. So the y-intercept is 36.
So essentially, C.
Yeah, it is C. Yeah, you're right.
Wait, what?
He's saying it's just this last number because the other two are 0.
Oh, because you have to plug in the 0 with x bar. Okay.
Yeah,
Okay.
so it just becomes C. Yep, and make sure you write it as a point. Again, x is going to be 0, and then the y-intercept, 36, is going to be your y value. You just plug in 0 for x. It's just C, like he said. It's just the last number. Now, I want to take a look at this graph real quick before I'll let you guys work on the worksheet. We'll do the other example tomorrow. But I do want to see what this graph looks like, just so you can kind of see everything we found. So it's 3x squared minus 24x plus 30. Okay, using Desmos, which is a great app. I like it a lot. It's easy to graph stuff. First of all, we can see the vertex is 4, -12 down here, which is what we found. See if I can make this a little bit smaller so we can fit it in the window here. There we go. Nope, not that. Let's try this again. Okay. Next, we had x-intercepts, which we found to be 2 and 6, which makes sense. It's where it crosses the x-axis. We can see the axis of symmetry is right down through there, which is at x equals 4. We can see it's pointing up, something else we found. And then finally, the y-intercept. We can see it crosses the y-axis at 36. So if you want to use a graph to check your work, feel free to do so. Everything should visually make sense. That's pretty much it. Oh, range. Range goes from -12 to infinity, so we can see all the y values take on that. Domain, of course, is all real numbers. Shape is a parabola.